Okay, so welcome to our virtual robotics fun hour. My name is Melody and I'll be the host today. So I wanted to talk about our FTC crash course that we're going to be having. It's a beginner crash course on getting started with FTC, and you can learn all the basics of the FTC robotics platform. There's a link to the sign up on this slide. Also, we're going to have a youth robotics fair for our virtual fun hour on June 19th into the 26th. So on the 19th, we're going to have a junior FLL and FLL robotics presentation and demonstration along with RoboCode. And then on the 26th, we're going to have the junior FLL and FLL team members robotics project showcase. So now I'm going to just play this trailer. Everyone hangs on it really quickly. My second-year-old hangs on this too. Okay, so for today's online resource, we're going to be talking about Kubo robotics. So Kubo coding introduces concepts of functions, loops, and subroutines. And there's also hardware that you can buy to work with Kubo. So there's Kubo Coding Plus that adds dimensions of time, distance, speed, and direction. And then there's Kubo Coding Plus Plus as well. Okay. I'm gonna erase all of this. Okay. Okay, so Kubo Play is a simple online coding platform, and it's developed in Unity, and there's free access to all of it during school, and there's no account needed. So there's different tasks that you can attempt, and the recommended age range is from kindergarten through 5th grade. So now I'm going to do a quick demo of one of the tasks. So that's the Unity logo. And here, there's tasks that you can attempt. Today, we're going to be doing the loops task, and you're going to go around the campfire. So I'm going to start by showing you guys how to do this program without using loops. So I'm going to start using these tiles. So first, I'm going to put the start button for the Kubo robot right here. So that's where it's going to start. And then these blue record buttons are what the robot's going to record and perform. So the first thing it's going to do is go straight, and then turn left, and then right, and then it's going to go straight again, and then right again, and then straight again, and then right again, and then straight again, and then right again. And then I'm going to put the end right there. And then I'm gonna have this robot, I'm gonna put it on here, and it's basically gonna record what's in between the two blue record buttons. And then I'm gonna place it on the start, and then it's gonna perform that task. So as you can see, it's going around the campfire. Okay, so does anybody realize, like, does anybody see a pattern here that we could use a loop to replace? Because I had to drag the same set of tiles quite a few times. So does anybody see like a pattern? Okay, nobody's, yeah, so William T said turn right and move forward. So that action happens 4 times. So I'm gonna use a loops instead. So I'm gonna do the same thing. So first it has to go straight and then turn left. And then I'm gonna do a loop. And it's gonna go 4 times. And the pattern was turn right and then go straight. And I'm gonna put that to finish the loop and then the end record button. Okay, now I'm gonna have the robot. Okay, and then I'm gonna put it here, and you're gonna be able to see that it does the same thing as before, but the second set of tiles was a lot easier because I didn't have to drag the same tiles over and over again, and that's kind of why people use loops in programming, is you can do the same action multiple times. Okay. So now I'm gonna stop sharing my screen, and Austin is gonna share a screen, and he's gonna talk about the Burt mobile.
Okay. Hey guys, so I'm Austin, and today I'll be talking about Burtmobile, which is a project I worked on. So, Burtmobile was a project I worked on at MIT Engineering Design Workshop in the summer of 2019. It was a 5-week workshop where we focused the first week strictly on brainstorming, finalizing ideas, which shows that how important the first step is, as it's one of the hardest steps in the whole engineering process. So in the beginning, one of the key points that we had to focus on was to have quantity over quality. So we just try to get as many ideas out as possible to get our brains thinking. And at the end of the first week, we had over 1,000 ideas from 20 EDW participants. And then in the end, we had to cut these these ideas down to 5 different ideas. And everyone who had similar interests would be grouped into the same project group. So my project team, I had Sophie, who was a senior, Amina, who was a junior, and Aditi, who was a sophomore. So about Burt. So I found Burt when I was walking in the student center one evening, and I found a flyer on one of the walls about MIT alumni looking for people to build a toy for his special kid. And so I took the flyer and I brought it back to my engineering design workshop, and I brought it up as an idea. And other people were really interested in it too. So we got grouped together and we worked on it. So Burt is an energetic 4-year-old, and he was the focus of our project. He had a stroke before he was born, so he has difficulty with motor function, especially on the right side of his body and with bimanual coordination. He has trouble coordinating both of his hands together to perform certain actions. So the idea was to have a toy where the more he exercises it, the more skilled he becomes at it. So our objectives. We set our objectives to exercise Bert's right hand, adapt to his skills as he progresses, make the toy harder and harder to use and more advanced for his progress. Kind of indirectly make him use bimanual coordination because he's a kid, so you can't just tell him to do it. The toy also had to be appealing to him, but also challenging for us to make and create. So our project, it was an RC car with a personalized controller for Burt. The controller had 2 joysticks, a throttle button, a mode switch, and an on and off switch. So we had 2 modes for this controller. One mode would have the joystick on the left side be the directional joystick, which controls the direction, and a button on the right side, which would just be the power button. So as long as his right thumb applies a certain amount of pressure to the button on the right side, his car will have power and he can control it with his directional joystick on the left side. And the other mode would be when he's more advanced and his right thumb can control the power with the joystick. So same thing, left joystick is directional, but the right joystick can control positive power and negative power instead of just the button to press that. We had an electrical box inside the controller for safety reasons and a tapered edge for comfort. So products and materials we used, we had an Arduino board on here. This is for the controller. We had an RC car kit. We had lots of scrap wood at our to use. We had a LiPo battery, screws, spray paint, wiring, the XP communications device where one would go here, and this is all on the car, and one would be on the Arduino. And we had a motor controller at the top right that you can see here. So prototyping the controller, we had over 15 different prototypes. In the beginning, we used cardboard just to get an idea out, to show and like express our idea. And then we investigated certain controllers such as the Xbox controller and the PS4 controller. And you can see in the foil design right here. But we realized that was too hard for us to make without like industrial manufacturing. So we decided to go with a Nintendo Switch design. You can see these 2 cardboard pieces here. And then we started shaping it to our own desires and use these wood pieces here. So these wood pieces are done by hand by us. We used the bandsaws to cut them out and we sanded them down. And on these 2, we had finger straps on the back to sort of guide Bert's hand into holding the controller. And then we kept working on the shape, finalizing it, smoothing it down. But doing this by hand was very tedious and it was like a lot of time. So then we catted it and then we put it into our laser cutter. And the laser cutter gave us these 2 prototypes. And then we met with Burt once again. And we had him hold a few pieces of clay so we can get his precise fingerprints, finger molds. And the original idea was to bake these clay molds and use them on our final product, but they didn't turn out the way we wanted them to. So then we went back to the 2 laser cutted controllers right here. And then these 2 are our final ones where we can assemble them and take them apart easily using these holes right here. So in our controller, we designed it in Fusion 360, and then we put it in the laser cutter, which was really fast, easy, and accurate. It was also very clean and looks nice for us too. It looked really nice. And we can take it apart easily so we can investigate the insides. So the controller wiring was right here. Sophie spent hours wiring everything and then soldering the connections together. So in total, there's about like 40 connections she had to solder and make sure we're stable, so we didn't lose connection randomly. And we had to go through lots of testing of our controllers. It was a very tedious process. And then prototyping the cars. So in the beginning, we had an idea to make an RC train, car, airplane, or boat. But we went with the car because the other ones all had downsides. So if we were going to make an RC train, we would have to lay out a track for Burt, and he would have to carry a track everywhere he would go, which is very inconvenient. An airplane would be kind of dangerous for your 4-year-old to fly around. He might hit someone or injure himself. And then a boat would require a water environment and was very inconvenient. So we decided to go with the car because all he needed was a flat surface that he could run the car and drive it up and down on. So this is a DT working on the soldering joints of the car to make sure the motors are all soldered correctly, and we had to test it. We tested each side by plugging it into our LiPo battery here to make sure the wheels would run smoothly. And then this is us testing our connection for our joystick and the XP communication device. It's kind of a short video, so I'll just play it again. Okay, so building the car was probably one of the most fun parts, I think. So we used a big bandsaw machine you see here to cut off the big pieces of wood, such as the bumpers and the body of the car. So Sophie helped me cut out these pieces of wood, and then I had to go through many iterations of sanding these down to the right shape and right size for our car. So these weren't the first bumpers I made for the car. This is like the third time, so I spent like 6 to 8 hours in total on this car alone. Down at the bottom left was the windshield, the window for the car. I had to take a heat gun and slowly bend the acrylic into the right shape, and then I had to glue it together. And then I had to work on the body, which took a lot of sanding to make sure everything was even. And that took a lot of iterations too. As you can see, this part has the front right here, and this one doesn't. And this is the final controller design. So like I was talking about before, there's the button right here, and the throttle joystick right here, and the directional joystick right here. We also made the switch between the two modes on the back because we didn't want Burt to adjust it to his liking. We want the paired self-control. So we put it in the top left right here. So the parents just have to take the controller apart, which is relatively easy, and just flip the switch. And our final car design, so Burt really liked Hulk, so we had to laser cut an emblem for Hulk, and then we put it on the car. We spray painted it green. We put 2 purple stripes to match the car's theme of Hulk. So completing the product, after we finished the design, we had to test the controller and car communications, like the XP communications in the video I showed before. The controller packaging, so the height was a bit too small. The electronics were too big for the original controller. So we had to change the height a teeny bit, or not make it too big where Bert's hands can't wrap around the controller. And we also did lots of field testing, like running it around, driving it around ourselves. And so this is our final product with everything put together. And yeah, that's about it. Any questions? So the latency of the Wi-Fi controller, it wasn't that bad. It's not noticeable. Yeah, this is only for Burt only. It's a project purely for Burt. The latency wasn't that bad between the two XP communication devices. Burt, we met with him once and we showed his parents, but I think we're still working on it. Because after MIT was shut down during Corona, the workshop was closed. How fast can the car go? The car can go fast enough for Bert's enjoyment. That's all I can say. I don't really know a measurement. Any other questions? The chips. So we had a Arduino board inside the controller, and then we had a motor controller and another XP connection inside the car. So the Arduino came with the slots for the XP connection device, and then we had a separate connector or circuit board for the XP thing in the car. Let me just go back to it. So right here, so we can see this is where the XP went on the controller, and then these two would just be lying around on the underside of the car, and they'd be soldered together. If I can put a picture. Like here, the XP's right here, and then motor controller, so the XP's will talk to each other. Okay. How did we get the Arduinos? So I got the Arduinos from a website called SparkFun. We had like exclusive access to SparkFun because we were working under MIT, so we got shipping pretty fast. And that's where we got our electronics from. I got interested in building because of robotics, what I do every week. And so that was my main role of the project. So carving the wood took a lot of practice. It was not the first iteration that I did on that's not the first time. Like, it wasn't the first iteration that you're seeing. That was like countless hours of practicing using big machines, such as the bandsaw and the sander, and it's like a circle sander. And yeah, it took a lot of practice and marksmanship to get it right. So yeah, we made the car. Yeah, I had to smooth everything out, smooth the edges out, make the measurements, cut it precisely, and just paint it in the end. We only got the frame of it, and I had to put the colors on there and like the body of the car. And yes, the controller can control the car from a decent distance, enough to be in your peripheral vision. It's a Spark Fun. Spark Fun Electronics. So the process took around 4 weeks, and we're still kind of working on it, but we have stopped recently because of coronavirus. Okay, well, that's it for questions. Move on to the next one.
So now Max is going to talk about Unity. So Max, you can start sharing your screen now.
In this CAD session, we're going to be talking about CAD with Unity. Okay. So what is Unity? Unity is a real-time 3D creation platform where artists, designers, and other people can come together to edit and make iterations of their developments. There's also a concept of creating once and deploying anywhere, which means that a creator can make their product and deploy it to any major AR, VR, mobile, desktop, console, or TV platforms. Unity also has one of the best graphics rendering. So any games or other products that a person makes will be guaranteed to have some of the best graphics. So in Unity, there are multiple industries. The first one is the gaming industry. So incidentally, Melody's Kubo game was also made by Unity. Some other popular games made by Unity are Cuphead and Soul Knight. These are pretty popular the past few years. And yeah. Now we can just watch a short trailer of a game made in Unity. Okay, actually, hold on.
Doesn't look like much. Go take a look.
Yeah, that was the trailer. The next industry is the transportation industry. So notable car companies such as Audi, Toyota, and BMW have already used Unity for their purposes. Toyota in specific has used Unity to develop VR and AR technology to showcase their vehicles. Now we can just watch a short clip of this Lexus car made in Unity. Yeah, so this Lexus car was made in VR, but it still looks extremely realistic. So if someone had a VR version of Unity, they could look and see what the car
Can you disable the annotate? Because people keep drawing on the screen.
Oh wait, what if I do this? Okay. All right. The third industry is from film, and we can just watch a short clip of these trailers. Wait, can you guys? Oh, okay. Okay. Karina, could you stop drawing on the screen? Okay.
Max, you can disable annotation.
Wait, I don't know how. Is it?
Under more.
Oh, okay, my bad. All right. Yeah. And then the last industry is architecture.
Clear screen.
Wait, can you guys not see my screen?
No, they ask you to cleanse annotations. There is a button to do that.
Max, click on the annotate button and then press delete all or clear all. And then just
Oh, okay. Good. Oh, okay. All right. Okay.
Seriously? Hey, he's the star. It looks coming back slowly, all right? Level 10 is a kangaroo emo. I'd love to see that. Oh, there's another page. They've actually done, I think they've done all 100.
All right. Nice. So this video just shows why Unity for architecture is really useful.
constantly changing their designs, and so they'll give me something on one day and I have to import it, bring it into Unity, and then by the next day it's already changed and I have to go through that entire process again. Now with Reflect I don't. I don't have to do anything. I just build it once. They just have to hit the button on their end to send the data and it's done.
Yeah, so that's just shows how easy Unity is. So we first heard about Unity last year when we went to the World Competition. We saw another team using Unity to create a CAD model and drive it around. So we thought that was pretty cool and asked them how they did it. They shared some tips with us, and after that, we decided we wanted to make our own CAD model into Unity. So the image on the left shows shows an FTC field from last year in Fusion 360. And then the image on the right shows the same field, but in Unity. And once you import it into Unity, you can do a bunch of things that you can't do it from earlier. For example, you can code it, which we'll talk into a little about later. But you can control lots of stuff like the robot over here. And there are also cameras and lights where you can change and adjust. There are infinite possibilities. Unity takes only a certain amount of CAD files. So here's just a short list of some that Unity accepts. I personally prefer 3ds or FBX because those are the most commonly used and also the least likely to change your file in any format. The ones that I don't use a lot are OBJ and DXF because these are the ones that are less reliable and can change your model or file in some form. Unity uses C# to control and program its models. C# is really similar to Java, which I'm sure some of you guys know and are really familiar with. But other than that, Unity also uses the input manager. The input manager is what assigns parts to buttons on a gamepad or your keyboard. So for example, over here where it says type, it says key or mouse button. And that means you can either assign one of these keys to your keyboard or your mouse. But it's a drop-down that also lets you go to gamepad. And where it says joy number, under that is a bunch of different selections for parts of a joystick. So there's the D-pad, there's also the X, A, B, Y button, and all of those are under that. Lastly, here is a short video demo of our robot 2 years ago in Unity, which was actually recorded and controlled with a gamepad. Yeah, so that was just a short animation or demo controller. Okay, I guess now we can be open to questions. So if you guys have any, just drop them
Max,
in the
we're
chat.
actually going to skip over the question time and
Oh, okay.
go to the next
That's
session. We're running out of time.
Yeah. Okay.
Okay, so this is the RoboCode session, and some of you might notice that I'm not the one that's sharing the screen like usual. That's because today we're gonna have another person that's teaching. His name is David, and he's a coder that's been working with RoboCode for quite some time. It's actually his project for our upcoming robotics, youth robotics fair. So he's been working with it for a while, and he wants to share some of the techniques he learned. So today he's teaching linear predictive shooting. So David, you can take it away.
Oh, wait, oopsies. Okay, so hi, my name is David Hu, and today I'm going to be teaching linear predictive shooting. So what is linear predictive shooting? Well, linear predictive shooting is a type of shooting that basically predicts the movement of robots that move linearly or like in a straight line. In order to use linear shooting, we have to know one fact. The bullet speed is always faster than the robot. We can calculate the bullet speed by using this formula, 20 minus 3 times the bullet power. So that basically means the heavier bullets travel slower and the lighter bullets travel faster. The next thing we're assuming is that the target is moving in straight lines with no change of heading. With that, we have 3 steps to do linear predictive shooting. The first step is to predict the movement of the robot. We typically use a sample package walls because it moves in its movement is very predictable as to us, and it's a good example for this. We also use a trigonometry functions, sine and cosine, to help us predict the stuff. After we have that, we onto step 2. We have to find the intersection point of the bullet and the predicted x and y coordinates of the robot. But we do that by using a loop, a while loop. Once we do that, we're on to the third and final step. Since we know the coordinates of the robot and for the intersection point, we need to calculate the angle to fire the bullet. To do that, we use another function in trigonometry called a tangent. To understand what x and y are.
Hey, David, real quick, our other sessions ran a bit long, so if you could speed it up as much as possible, that'd be great, because we still need time for the tournament.
Okay.
Yeah, sorry.
For this is a coordinate grid. As you know, there's an x horizontal axis and a y, which is a vertical axis. Basically, this point is 0, 0. This is typically 0, 1,000, as in our RoboCode battles, because the battlefield's 1,000 by 1,000, and this is going to be 1,000 by 1,000. For the heading, basically the angle that the other enemy robot is traveling in, we use on a scale of 0 to 360, with 0 being up north and 180 degrees being south. To get that, we use a function called event.getHeading. It basically just tells us where the robot is heading towards. What is this? Oh my god.
Clear the annotation, Davey, and disable.
I did. Okay, so this is the snippet of code that we use to predict. As you can see, this is the predicted x, and we use a sine function. We multiply by the enemy's heading, and we also multiply the velocity. We do that the same thing for the y. For the next part, this part of the code, it's just in case that our prediction is outside of the boundaries of the map. Why you see 18 is because the robot size is an 18 by 18 square. So the next step we need to do is calculating the intersection point. Right now we're assuming that the wall robot is moving straight and it's not changing its y coordinates, only x. And then our robot is moving straight still. We know the bullet speed, and we also know the predicted x and predicted y. So now for our while loop, we keep getting new predicted x and predicted y until our bullet has probably hit a confirmed spot. For example, if right now time t, the robot's going to be here, we have predicted that the robot will be here at time t+1, and the bullet will have traveled up around over here in that time. As you can see, the bullet has not hit the robot. We do that again in time t+2, and you can see the bullet has traveled a little bit further, getting closer to the destination. And then at t+3, it gets closer until t+4. We have found the intersection point between the bullet and the robot. So this is the code. So as you can see, the time of the bullet flight times the bullet speed basically equals the distance that it has traveled. And you know your distance between yourself and the predicted x and y. So as long as the bullet is short, like one of these 3 lines, then we know to continue going until we get to one of these t+4 situations. In that case, we will break. There will be 2 conditions for the while loop to break out. Either we found the intersection point, or we have the boundary has been intersection is outside of the boundary. Then we just shoot the border. For the final part of the linear predictive shooting, we need to calculate the angle to fire the bullet towards the predicted X and predicted Y. So right now we're assuming that our gun is facing north and that the robot is heading towards us east. All right. So you know your own coordinates, and you also know the coordinates of the predicted X and the predicted Y. So using a trigonometry function again, we use tangent. We first find the value of this side and the value of this side, and using trigonometry, we can find the value of this angle too, and that will tell. We store that value in angle theta, and in theta, we're going to return that to our code, and it would our robot will turn and turn angle theta and shoot that place with the given bullet power. So now I will show you a demo between a robot that has predictive shooting and one that does not have predictive shooting.
I'm not hit. What is that aim?
So right here. So this, this is between TrackFire and the wall. As you can see, TrackFire does not use linear predictive shooting, and it's very rare to hit the robot. As you can see, the robot just keeps moving outside of the range. Now, if you want to see a robot that has a linear predictive shooting, I'm going to add my robot in. As you can see, it's predicting basically the movement of the robot. You see, it will like always fire ahead of the robot, so it will to hit the robot. See, my robot easily defeats the robot, the wall robot, without taking that much damage. So that basically is it. Now, today's homework is going to be to make a robot that uses linear predictive shooting of some sort to beat the wall robot. The wall robot can be found in the sample package. And if you want some code to help you get a head start, there's some code by Hank right here to help you. Now, moving on to the next section.
Sorry. The next session is going to be the tournament. So if you could stop sharing your screen, David,
okay,
I will take over, and I'll be running the tournament as usual. All right. So let's go back to the tournament. Robo challenge. What the heck? Let me see. Disable annotations. This is black screen. X.
Byron,
Yeah?
you have to disable annotations.
I did.
Those are annotations. You have to delete them first.
Oh, clear all drawings. Oh, okay. Jeez. Who keeps annotating? Okay, whatever. Anyways, we're gonna be holding the tournament. Real quick before we start, we have started the tournament a bit later than usual, so we might have to go a bit past 8. Again, if you need to do something, you're free to go past 8, but we encourage you stay, because we might have to hold the rest of the tournament and the Q&A past then. But without any further ado, let's get this moving. This is actually tournament 5. And yeah. So in Division 1, we're gonna move straight to finals because there's only 4 people. So actually we're gonna start with Division 2 because Division 2 has qualifiers. Division 1 is finals. So like before, out of these 5 robots, we're gonna choose 1 out of 5 to get a bye. So random number 1 through 5. 1. So Spinner is gonna get a bye, and then Ramba, Axis 9, Panzer, and HG2 will go to the qualifiers. The last place robot will be eliminated, and then the remaining 3 plus the one that got a bye are going to go to finals. So let's start this off. Decline. And it's going to be 1-round qualifiers. Shoot. Let's just start that again. And full screen it. And the Division 2 qualifiers are live. That was really quick again. But to sum it up, Rambot, that's Nathan's robot again. Rambot is in first place, despite not being the last robot standing. Anyways, Rambot is in first place, Panzer's in second, HG2 is in third, and Axis 9 is in last place. So unfortunately, he's going to get eliminated. And Division 2 finals will be Rambot, Panzer, HG2, and Spinner. So now let's go to the Division 1 finals, which are going to be Beast Node, Mojo Jojo, Chimps, and High. So this is going to be 3 rounds. And let's start it off. Okay, this is a lot more relaxed than the super quick Division 2 qualifiers. We turned on the speed a little, and it looks like the robots are firing. Doesn't look like any robot's been eliminated, but Harder Than Chimps is getting really, really low. It gets defeated. High actually gets disabled. Mojo Jojo the Destroyer and Beast Node are still firing wildly. But it looks like Mojo Jojo definitely is at the disadvantage. It doesn't have a lot of energy left. It gets disabled and it gets destroyed. On to round 2. Right away, it seems like Beast Mode is actually being damaged a lot, but it's got a lot of energy back. Harder Than Chimps is actually really low again. It's going to get destroyed first again. And now the robot's just firing bullets. Looks like High just got destroyed as well. It's down to Beast Mode and Mojo Jojo the Destroyer. Beast Mode this time looks like it has much less health. It's going to get disabled. Now all that's left is for Mojo Jojo to get the killing blow. It does. And now for the final round. High actually looks like it's got stuck against a wall. It's firing against a wall there, not getting a lot of points. And it's just going to slowly run out of energy. It looks like actually Harder Than Chimps got destroyed again. Mojo Jojo the Destroyer also gets destroyed. Now it's down to only High and Beast Node. And Beast Node's shots are going wild. But High is just firing at the wall. Occasionally, it is firing to Beast Node. But it does get disabled. And that leaves Beast Mode, the winner of Division 1, with 878 points. Followed by second place, Mojo Jojo the Destroyer with 509 points. And then High with 329 points in third place. And finally, Harder Than Chimps with 112 points in last place. Good job, everybody. Okay, now let's move on to Division 2 finals. So Division 2 is going to be everybody except for Axis 9, who was eliminated in the qualifiers. And we're going to check 3 rounds. We're going to start the battle. We're going to slow it down a bit. Okay, Rambot is Nathan's robot is doing its signature ramming. It gets taken out, but not before it destroys Spinner. Now it's just between Panzer and HT2. With Panzer having the advantage in energy here. But it looks like HT2 is evening it out just a little bit. It's going to be close. HT2 is going to take this round. Rambot starts ramming again. It gets actually the first one to be destroyed. Spinner is soon to be taken out too. Now it's HT2 versus Panzer once again. This time Panzer, the clear winner. Now Rambot has locked on to Panzer, but Panzer actually comes out the winner. It is pretty low on energy though. It gets taken out. Now it's just HT2 and Spinner. And Spinner has the energy advantage, but how long will that last? Spinner's bullets often seem to be going wide. HT2 bullets. He's not landing everything either, but he is hitting some. And at this rate, Spinner is soon to be destroyed. But can HC do it before he runs out of energy? Please stop requesting remote control, by the way. Anyways, HC2 is going to take the final round, but not the rank 1. That's going to go to Panzer with a score of 782. And rank 2 is going to be HC2 with a score of 646. At rank 3 is going to be Rambot with a score of 373. And unfortunately, at last place is going to be Spinner with a score of 263. Good job, everybody. Okay, let's go over chat real quick. And then we can have the people, we can have everybody. It didn't copy fully, okay. Okay. Good job, everybody. Now we can move on to going over the top robots. So I'm gonna be opening up the coder's screen and their code, and I'm gonna ask whoever coded the first place robot to talk a little bit briefly about their robot. So let's get started. We're gonna open up source editor. And let's start off with the winner of Division 1. William, are you here?
Yeah.
Okay. Can you talk about your robot Beast Node real quick? I'm just gonna pop it open.
All right. So beast mode. It looks pretty advanced, but I guess it's not that advanced at all. It just like the code is just like really long. Good is because of the I didn't do predictive shooting, but I guess I did like a guessing shooting, not like literally like linear prediction or anything like that. I just kind of like guessed, and yeah, and down there like the if loop is like it predicts like how it shoots. This stuff is all on the most of this stuff is on the API doc. So it's like I got most of the info from the API doc. And I took out the on hit by bullet event because beast mode is good at like combat with another robot, and he like when he's close he gets hit a lot. So I made it he turns perpendicular to the bullet, so like it's like most likely gonna dodge like shots that come after the shot that just came. And I also added a event that I found on the API. It was the on hit robot event. I think that's pretty important to like go against like robots that are like rammer and that stuff. So here I just I made an if loop. So if the robot is ahead of us, he'll most likely fire. So I use like a fire mechanism to know where he is. So if he's ahead of us, we go back. But if he's behind us, we go ahead. So that's kind of what I do. So when like a ram robot comes, I back up a little the other direction. So you can't really get a lot of damage in.
Yeah, that's really neat. We haven't seen a lot of ram robots in Division 1 yet, but if there is any, that's definitely a nice way to handle it. Besides that, yeah, all this is really good. I'll point out that you spelled acquired wrong, just a little thing that bothered me. But wow, when like spelling errors aside, your actual code is really good. Yeah. I love that you went into the API and searched up stuff, because that's a really good way to find new commands and find out different things you can do with the robocode, because there's a lot of info you can get. Yeah, gun turn amount.
And
yeah.
Coach Goo, might know him. Coach Goo also helped me. Like I had like sessions with like Hank and David and like Isaac, and like we would like work together and solve our like problems, and he would help us out.
Yeah, that's really cool. Okay, whatever. Okay. Well, good job. This is one of the most advanced Division 1 robots I've ever seen. So that's pretty nice. It's good to know that Division 1 is advancing. At the beginning of Division 1, we only had a few robots, and most of them were basically my first robot with a few numbers changed. But now they're getting more and more advanced. So it's really good to see. everybody making progress with their robots. Now let's move on to Division 2. And its winner, Panzer by Adrian. Wait. Adrian, did you win last time?
Yeah, I
Yeah.
think
Yeah, Adrian won. Okay. So, yeah, sorry, Adrian. Really good job today. You managed to win 2 times in a row. But since we want more people to share their thoughts so that we can get like a wide range as possible. So we're actually gonna move down to the second place for this time because we don't want anyone to speak more than once. So sorry, Adrian, but we're gonna move on to Hank, who I believe was second place. Yeah.
Yeah, awesome.
Yeah. Okay. So Hank, are you there? Hank? Okay. If he's not there, then I guess we can move on to Adrian again. Adrian, are you there? Adrian? Okay, if neither of the top 2 people are here, and Nathan's already talked before, he won a bunch of rounds a while back. I guess I'm just gonna open up, I'm just gonna open up, I guess Hank's row.
I think he is here.
Is he?
You can just-
Hank.
You're saying if that's you, can you unmute yourself, please?
Yeah, yeah. If Hank or Adrian, I guess, are here, can you please unmute yourself and talk so I know? I'm sorry, Melly, I can't see. Are they unmuted?
He says last time you guys said my mic wasn't good.
Oh, Adrian, yeah. Is Hank here? Is Hank here? Yeah, Hank Chen, HC2. Okay, it looks like Hank isn't here. So, I don't know. Yeah, Adrian, can you unmute your mic and try again? Maybe it was just a one-time problem. If it's still unclear, we can have you type in chat again. Or I can just go over your robot. Adrian?
He's unmuted.
Okay, Adrian. Are you talking?
I think that he's talking, but we can't hear him.
Hello, Adrian, if you're talking right now, can you please type in chat? You tried? Yeah, can you try again? Just leave your mic unmuted. Unmute your mic and just start talking.
Hello?
Yeah. Yeah. Well, we can hear you. We can hear you.
Okay. I pretty much had the same stuff, but changed the velocity part that would actually change the max velocity.
The velocity thing?
Yeah.
Yeah, here. Actually, it should
Or it's
be.
kind of just all over the place.
Yeah. Oh, so did you change it according to what Coach Goose said? Like it's above the maximum velocity?
Yeah. I just changed the adding instead of adding 12.
Yeah. So it's over here. Oh, this looks like it's the same as before.
I changed it how much at the last one. Instead of plus 12, it was plus 2. So
Oh, it's plus 3. Isn't that still? Huh. Math.random. What does it do? Is it between 0 and 1 or?
Yeah, that's random means 0 and 1. So occasionally it should work, but it's not working all the time, I guess.
Oh, so it's either the maximum velocity or it's 3.
What?
I guess. Is that how? Is random like a random integer between 0 and 1, or is it like
it's
any number?
I think it's floating, but I need to check the API.
Huh.
Pretty
That's,
sure.
yeah, I've never seen math.random without any like the min and the max parameters.
And
Anyways,
then
yeah. So a few techniques you can see in Adrian's robot here. We went over these last week, but if you guys weren't here or if you were, Adrian he tries to randomize his velocity so that it's hard to predict your motion. Actually, if you look back on David's, code is assuming that you're always moving in the same speed, and that's true for a bunch of robots out there. But Adrian's robot actually randomizes its velocity, so it's harder to predict where it's gonna go. And then a lot of other things. He actually has different behaviors. So if you see these if statements and else if, he has different behaviors depending on how far the enemy robot is to his robot, because uh, because obviously if they're farther away, then the puller has to travel longer, so it's harder to predict. And you can actually see that predicted X. Are you using linear predictive shooting, Adrian?
Yeah, that looks like almost the code David talks about.
Yeah. So this is basically the code David talked about, where you use trigonometry, sine and cosine, to determine to try to predict the enemy robot's position and then fire. Yeah, so you can see that it's actually a really powerful technique. And Adrian got first place in Division 2 2 times in a row, actually, with his predictive shooting. Yeah, a lot of different things here. Okay, it's already past 8, so we're gonna move to Q&A. Good job, everybody who submitted their robots. Oh, a quick note. Please remember to submit your robots. Yeah, we have the form here, and we send it out every time we have the email. Because if we have more robots in the submissions, then it just makes for a bigger tournament, and we all have a lot more fun. So just please remember to submit your robots whenever you can. Anyways, with all of that done, we're just gonna move on to question and answer. Yeah, good job, everybody. Good job submitting your robots. I'm gonna stop sharing, and we're gonna have everybody just ask questions in chat. After, if you don't have any questions, or if you have something to do, you're free to leave if you want. How do you create a robot? Okay, so we went over this quite a few lessons ago. So first, I'm gonna show you how to actually do it. So I'm gonna start sharing my screen again, and then first I'm gonna start sharing my screen so I can show you how to create a robot, and then after that, I'm gonna show you where to find our previous side, so you can see all the stuff you missed. Because if you don't know how to create a robot, then you probably missed a lot of stuff. So you're gonna want to open up your robocode. If you don't have robocode installed, then the instructions for that are gonna be in our previous slides. But you're gonna open up your robocode and then go to Robot Source Editor. So, or you can just press Control E, and then that's gonna open up this screen. But there's not gonna be these robots open, so it's just gonna look a bit like this. And then what you want to do is you want to go to File, New, Robot. Name your robot. I don't know. I'm just gonna name it something random, but try to name yours something descriptive and something easy to say. Because when I commentate, I have to say out the name of your robot. So don't make it too long. Don't make it too, I don't know. Yeah. And package name, we recommend you use your initials. So in my case, Byron Lee, my initials are BL. So then we're gonna create our brand new robot like this, and you can edit it however you want. When you edit it, say you want to change something back 10, you have to save it first. So Control S, and then you have to save it, and then you need a Control B compile it. And if it shows how compile successfully, you're good to go. Okay, and then with that, we're gonna be sending out these slides afterwards in our email. And if you click on this link, it's near the very end. It's near the very end. If you click on this link, you go to this page, and if you scroll down, you can see all our slides and install instructions for previous sessions. So if you're brand new, you can catch up right here.
Byron,
Yeah?
Hank said he was back. He was eating dinner.
Oh, sorry, Hank. Actually, Well, we already had Adrian talk, and we're already on to Q&A. But is there anything you want to share about your robot? Any techniques? Actually, William said, do you have any tips to make your robot stronger? So your robot is super strong. It got second place in Division 2, which is like all the advanced robots. So can you share a bit of tips, like how you made your robot? A bit of info about your robot, Hank?
So first of all, I used linear predictive shooting, which David basically explained. It's just basically use like trigonometry to calculate where the enemy is going. And I also use the set turn right radians infinity to like always scan for robots. And then I just basically try to come up with an unpredictable like movement. And yeah.
Yeah, so linear predictive shooting, David went over that. And then on move.
Yeah, I think Hank, you were using a wall-like movement.
Yeah, but I changed it.
Can you pointing out which line you changed?
Is it actually this?
I changed set turn radians, right? I added that in. I changed the peaks. I changed the set ahead move amounts. And I also changed the colors, and then I changed to make it set the gun when you turn.
So walls like movement. So I assume it's this. He moves the max amount of the battlefield's width, and then he uses that to find your way to a wall. And then after you're on the wall, then you can scan your robot around and fire other things. Because if you're on a wall, it's a lot harder to hit you, right? There's only 2 angles that are open. So yeah, so that's a way to make your robot a lot harder to hit and dodge some bullets that way. Yeah. So good job, Hank. Some tips in there. Have your robot find its way to the walls, so it's harder to hit. And linear predictive shooting is really good for hitting more bullets. Okay, I didn't see any more other questions in chat, but can I please add a note to please stop spamming faces and everything? I know I've been typing in chat a lot of these Zoom meetings to keep chat questions only. That doesn't change when I'm talking or sharing my screen, okay? Just because I'm not there to remind you guys to keep the questions only doesn't mean you guys can have fun making faces, okay? Like it's fun, but it distracts everybody from the actual questions and it makes it harder for the presenters to scroll around and find the actual questions. Besides that, are there any more questions? What can you change for your robot? What do you mean? You can like once you create a new robot, you can change like just about everything inside here. Let me close this and go to our menu robot. So I'd recommend you not mess with this part or this part, but everything that's inside of here, everything that's inside of this while loop, inside the on-scan robot, the bullets, you can change all of that to do basically whatever you want. And if you want more info on that, you can again check our previous slides and our previous recordings. Yeah. Is there anything else? Once you name your robot in the beginning, can you change it without making a new one? I'm pretty sure you can. So let's change this to change name and save it. Yeah, and it says that this should be saved in here instead. Would you like to save it there? And you press yes, and then you save it again, and then you can just compile it again. And that's basically how you change your name. How much energy do the robots start out with? It's around like, oh, actually, I don't know the exact amount, actually. I mean, we can test it out. Coach Guru, do you know the amount? I think it's around 150 or so. New.
Sorry, well, what was the question?
What's the amount of energy that the robots start out with?
134, I guess.
Yeah, they start with 100, as you see here. A quick note about energy. So energy is what you use. Energy is basically like the all-purpose statistic in this game. You use it to fire bullets, and you lose it when you get shot. And also, when your bullets fire someone, when your bullets hit an opposing robot, you also gain some energy. So that's how you see people having over 100 energies. How do you download Robocode? We have instructions right here. So I already showed you how to get to this this site, and then we have Robocode install and set up instructions right here. Yeah, if you want the TLDR, just literally just search up Robocode code install in Google, and then the first link that pops up will probably be like a RoboWiki page, and it has instructions too. There's a download page. Yeah, it's all here. If you have any questions about install or your robot or code problems or anything, you can just email me. My email is right here. I'm typing it out in chat right now. So feel free to email me. I'll respond as soon as possible. Any other questions? How can I access that link? It's in the slides. So we sent out these slides. We sent out these slides to everyone's email after each session, and then at the very end of it, there's this link. Did you get the email to? Did you get the reminder email? I think yesterday that had like the Zoom code and a bunch of instructions. Did you get that email, Jeffrey? If you didn't or you're not sure, oh, it was sent to my dad. Okay. If your dad's in the email mailing list, then ask your dad after this. Yeah, but if your dad's in the email mailing list, then just ask him like on Monday, I believe is when we send it out. Oh, wait, when do we send it out, Melody?
I'll send it out right after this session.
Yeah. So just ask your dad like a few hours from now, and then ask your dad to check his email, and he'll find the email and the link to the slides, and then in the slides you can find this link. Yeah. Any other questions?
Okay, if not, then I think we can end this session here.
Yeah.
Okay.
Thanks everybody for coming.
Thank you.